3 of the engine series is happening as you watch this. So part 1, we got the block, talked about how I got it. Part 2 was miking the bores, measuring out, seeing what condition the block was in. This part here, I am going to be cleaning up the cylinders as best as I can, which will involve using a ridge reaming tool and then using the 3-stone bore hone. We'll go through each cylinder, clean them up as best as possible, and then get a measurement again on where they stand and determine whether or not this block was rebuildable as it sits. Still sticking with the fact that it's going to go to the machine shop eventually and get the full 30 over treatment on it. This is now more instructional, and for you and me, anybody who watches this, I'm learning as I do this. So I just want to know whether or not this block, in the way I got it, could have been rescued, reused after 50 years, roughly 47 years of sitting around, and we're going to find out. So we'll go over the tools we're going to use to do this, and then the application of the tools, and we'll see what the results are. Okay, the first tool we're going to use here is the ridge reamer. This is a really slick tool. For as precision as it is and durable, they're not expensive at all. You can rent these at a few auto parts shops, hopefully around where you live. You can just rent one, kind of like you would rent a spring compressor or something, and then return it on a loaner tool program. But they're so inexpensive that it's not going to kill you if you have to buy one if you can't find one locally. So I went ahead and picked this one up from Napa. The mechanics of it, it's a pretty stout little device, and what it does is it clamps down with these 3 legs and auto centers itself in the block. If you look at the legs, they're chiseled, so they have a little bit of an angle so that they're not digging into the side of the block too badly. Then you've got this top that's tightened down with this top nut. Then the center part rotates about a shaft after you have it locked down and cuts with a hardened cutting bit there. As it rotates up, winds up, it will cut out the ring ridge that you've developed or any really bad carbon deposits you have towards the top of the cylinder walls. And you just wind it down with this nut right here that controls the cutting surface right there. These slides right here allow it to adjust out towards the cylinder wall. This one's brand new, so it's kind of tight, but trust me when I say this part here up top telescopes out, clamps or puts the cutting surface right up against the side of the bore. And then there's an adjustment for the blade here. There's a retract, I don't know what the first setting is, but 2 and 3 are the settings that it says to use when you do this. 2 retracts it, and then when you're ready to cut, you got everything set up, you turn it to 3. That extends the cutting bit right here, and you start winding it out, and it will start cutting out the bore. So we'll go ahead and get this set up in one of the cylinders and show you how it operates. Okay, so here's the cylinders, and you can see where there is a marcation here where the piston ring stopped its travel, and you will see on some bad ones here, like this cylinder here, there's an actual gap between the very top of the cylinder that saw almost 0 wear over the life of this block, and then the wear surface on the outside where the piston rings were doing their job. And you can actually see this little scale of rust that did come out with a quick hone. It's because there's a lip right here. You can hear this. I'm sure you can. There's a lip in the cylinder. So when you use your honing stone, it's going to sit here. It won't cover this area because it's just going to touch down here, and you will be scraping right over the top of that and never make contact with it. So you need to get rid of that ring ridge. And to do that, we'll take the ring ridge tool. We're going to set it in the bore, lock it down, and when you set it in there, you want the cutting ring, the cutting blade right there, below the ring ridge, fully below it. There's a little diagonal chamfer on the blade to help it start cutting before it gets to the full cutting length down there. So you want to get it below so it doesn't just grab that ring all at once and bind up. So it's got to start cutting slowly towards the top and then work its way through the rest of the ridge. So start with that down. Right now I've got this, I used it in another cylinder, learning how to work it. I've got it extended. So what you're gonna have to do, and this works counterclockwise, so it's lefty tighty, righty loosen, but you'll wind this all the way down. I just said that and I can't even follow my own advice. So you wind it all the way down until it's made contact with the bottom. Then you will go ahead and lock it in to the cylinder. There it goes. These threads have got some grime in them, so they're a little tight to work. But you'll see it's winding down from the top there. Keep moving it down here. Should have had this already set up, but this is that filler part of all the YouTube videos where a lot of people usually just play music or do slow-mo. Yeah, I'm just entertaining you with twisting a screw down. Bonus content, everybody. All right, so we got that pretty far down, enough to where I can set it in the block. So you'll need the right size wrench or socket to grab a hold of that. I already got it over here on the grabber. Oh, dearie me. Just a moment. There she is. I need that, and I need my 10mm wrench. So we'll get those over here. Finish winding this down. Helpful when you put this in the cylinder, you want to hold it from the top, drop it down into the cylinder, and then put your hand underneath to support it from the bottom while you tighten this top nut to get the clamps to bite into the cylinder wall. So that's what I'll do here in just a second. Okay, so I've got the device locked down in the cylinder bore. So now what you got to do is move the top, slide it till it makes contact with the sidewall of the cylinder, and make sure your cutting blade is retracted. Then you'll lock these down, these little lock nuts here. Make sure it stays pressed against the cylinder when you set all this up. Tighten those down. Now, depending on the size of that ring ridge, you may have to make 2 passes at this. It may bind up as you get close to the worst part of the ridge. And if that's the case, you just reset the blade back down and then recenter it against what you've already cut. That'll adjust the depth of the cutting blade, and it'll make it a little easier to cut the rest of it. I ran into that in one of the other cylinders I already did. All right, so we've got that locked down against the cylinder. And we're going to take the cutting blade, move it to position 3. See, there's a 3 there, a 2 there, and a 1 over here. So she's ready to cut, with the exception of some lubrication. So I'm going to grab some WD-40. Make sure you lubricate everything there. I discovered I did not have a 15/16 socket, so I'm just using some vice grips to grab the wheel to start cutting it. And then you will just wind, and you'll hear that scraping against the side of the cylinder, and you'll hear it get more aggressive as you go, and that's it, taking out that ring ridge. I'm going to see if I can find a little better mount system here real quick. Be right back. Keep adding some lubrication as you go. And you just keep winding away. Now it looks like we're out of the cylinder there. So wind it back down a little bit and reset it and make a second pass here. Find a... Well, my Achilles heel is putting things down at the most convenient spot at that time, and then not remembering where that spot was the next time you need it. There it is, right under the tool I just set down. Was the one I wanted, so it was covered up. Genius. So when you reset this, you got to turn the position back to 2. Retract your top plate. This gets a little difficult because it gets all those metal filings in there, so sometimes you got to give it a little tap. And then you will just wind her back down the cylinder and reset it. Keep this tight so it doesn't fly out on me. Wind her back down to the bottom. All right, there she goes, and then we'll clean off that cutting blade a little bit. Get some lubrication on that. And push the top plate back into the cylinder wall, tighten it back down. All right, then we'll set that cutting blade. Well, actually, I had it on 3. Forgot to set it back to 2 in this reset. And yeah, it makes a difference when you're trying to center this on the cylinder wall. Tap, loosen her up. All right, there we go. So now we'll tighten it back down. All right, then we'll set our blade back to 3, and then we're ready to cut again. Get a little towel here. Grime off me. Set the Screw Winder 3000 specialty tool here, and wind back up for a second pass here. You can really hear it working as it hits those high spots of that ring ridge. And it will get harder as you get up very top of the cylinder where the fire ring is, where the head gasket sits. There's always some carbon or crud built up right there. You get past that and you're done. All right, there it is. So take her out of the cylinder here. As they say, removal is the reverse of installation. I guess that's usually backwards. It's installation's reverse of removal, but it depends on how you look at it, right? All right, that's in there. Get your wrench or socket, just loosen up the top nut to get the wings to retract. Get a cleaning rag here and we'll wipe the cylinder down. So I'm just going to take a quick inspection with my finger. Yeah, we still got a little ridge up here, but you can see from before, let's see if I can zoom this in for you. Work the old Pro Go here, maybe not. Apparently you have to work zoom when this is stopped. So anyway, I think you can get a good shot. Looks a lot different, and you can actually see this has actually scraped some of the rust off, so it's actually gotten flat against the cylinder wall here. I've just got a little bit of ridge left right there, so we're going to go ahead and make a third pass on this one. So as I mentioned, you want to reach in from the bottom. Well, first you got to retract your device. You're all the way down. There we go. So you want to hold it from the bottom as you tighten the nut, and make sure your cutting blade is below where the ridge would start. You don't want to tighten this too much. Snug is good enough. Slide. All right, I'm going to recenter that. It looks like a little oblong to the cylinder there. So we'll just loosen it back up. What I'm looking at is, it looks like one of the feet didn't quite, is a little uneven on the cylinder wall. It's kind of canted this way a little bit. So just want to make sure that's square before we start. And get that blade about where I want it there. There we go. Oh, yeah, that's much better. All right. So move that out. We're in position 2 to start, right here. And then we'll lock the top plate down. Set the blade to position 3. A little lubrication. And the vice grips. All right. And we'll make sure my camera hasn't slipped here. You can still see what I'm doing. Yep. So we'll take her back up again. It's such a neat little tool. Honestly, you could, I think, with a little more work on this, a little bigger one, you could bore an entire cylinder to a certain specification. Of course, that would be a very expensive tool, but I'm sure it would be cheaper than taking it to a machine shop. They could design one of these to do an entire cylinder bore. All right, back to the top here. Unwind it a little bit. Retract our blade. Loosen up the top plate. Retract there. Now, when I'm tapping that, I'm just making sure I tap this machine part up here, not the blade itself, for sure. I'm gonna watch that. I don't want to nick or damage that blade at all. Get this guy out. All right. Let's give the cylinder a wiping down here. Yep, that's done it. Look at that. So that ring ridge and that cylinder bore is completely gone. Cannot feel it with my fingernail at all. And you can see a lot of that rust scale is now bright silver, or gray, not bright silver, but it's got it. And it's actually taken some of that cylinder rust away as it ground it down. So that's step 1. Now, step 2. I'm going to set up that step and be right back. All right, step 2, the honing stones. This is a 3-stone hone. These are terrible, honestly. First of all, they're really not, you're not going to get any meat off the cylinder wall by using these, to speak of maybe 100,000th. These are for polishing and getting a crosshatch pattern in. This is a medium grit. I think it's like a 240 stone. And we're basically just going to use it to get the rest of the scale off that cylinder and make sure it's as smooth as possible. So when I take those measurements that I want to see in that cylinder bore, they're as accurate as possible. So what you want to do is you want to lubricate the stones themselves before you slide them into the cylinder bore. Just spray them down with WD-40 or PB Blaster or some machine oil. And you also want to spray down your cylinder. Then you'll collapse your stones and slide them in. You're going to move an up and down motion here at about, well, the pace, you have to learn your pace. Not too fast, not too slow. That doesn't help you, I know, but that's all I can tell you on that. And the drill speed, you want probably somewhere around 600 to 700 RPM. This drill I have has like a 1300 RPM maximum, so I'm kind of just guessing halfway on the trigger for that speed I'm looking for. Too fast, you'll burn it. Too slow, you really won't get anything done. So we'll go ahead, and when you start it, you want your stones in the cylinder completely. When you're moving it up and down, you don't want to go past the bottom of the cylinder because you will hit one of the the iron pad for one of the main the crank journals down there, and it'll bust your stone. And it probably isn't going to hurt the engine any, but it's going to hurt your wallet because you'll have to buy a whole new one of these, and they're about $30 to $50 each for a good one. So just be careful you don't go down too far, and when you come up, you don't want to come up too far either. You can watch when you spin this, you'll see that line form kind of like a rotor blade in a helicopter, and you just use that to judge when you're at the top of the cylinder, and don't pull it out too far. So we're going to go ahead and start this one. All right, you saw when I was done, I pulled it all out in one motion. You don't want to stop with them in the bore. It'll mess up your cross hatching. So just pull it all the way out. There's a lock. Those won't fly off on you, or they shouldn't anyway. And just stop it after you remove the hone from the cylinder. Now look at that guy and how nasty and gray it looks compared to the nice shiny one right here. That's slurry. That is lubricant and iron and part of the stone material that you need to now wipe out of the cylinders. So get you a clean rag. I don't have a clean rag here, but I have shop towels, which I know are the absolute public enemy #1 of engine building. You don't use a paper towel to do anything, but this is going to the machine shop anyway. And even if it wasn't, after you do this, you're going to do a complete engine wash, soap and water, blow dry and everything anyway, so this isn't going to matter what I'm doing right here. All right, so now you look at it and we're down. We just got that little marring of that carbon ring right here, and I'm feeling with my finger. I can't feel a sharp line, but I can actually feel a bit of a high spot right here. So what to do about that? Honestly, I'm not going to put a lot of effort into it because this is just to show you guys how to use these two tools. And it's going to the machine shop anyway. I'm not going to spend hours trying to get this little high spot I feel right here out. The stones I have wouldn't do it, and I'm not sure it's so smooth now that the cutting wheel from that ring ridge remover would even catch it to start chiseling it out. So we're going to just go with that right there. And we'll get a few measurements on this now using that dial bore gauge that I showed you all how to use in the last video. This should still be calibrated, but never trust. Always, before you take any new measurement, recalibrate your tool. Yeah, it was still real close. Still right on zero there. So that's a good thing. We'll go ahead and take it from the top. And it is shock of shocks, right at 4 inches. So right where there was no wear from moving part, there's no wear on the cylinder. And exactly what you would probably hope to find there. Now moving down is a different story, of course, and I've gained 35 hundredths of a millimeter halfway down, and we've wore 42 hundredths of a millimeter at the bottom of the bore. Very slight taper, 7/1000ths of a millimeter would probably equate to 14/10,000ths of an inch. And I think that's within spec on taper, at least in that direction. But that's why you have to take two measurements going the other way. So this one, just ever so slightly, like 3/4 of a mil, of a 100th of a mil at the top. So that'd be 0.0075 millimeters. And we've got about 38 hundredths there. And maybe about 45 hundredths at the bottom on this side. Now, the taper on this cylinder I think is well within spec, but there is ovalness. And that's the primary reason this is going to go to the machine shop instead of just being built right now as it sits. Even though I can get this taper to within a reasonable, manageable margin, there's ovalness, and you simply can't take that out with anything that I know of other than a bore job. That ovalness is at the top. We got the difference between about 38 hundredths and 300. So 8/1000ths of a mil of ovalness going this way. In the middle, it is difference between 45 hundredths and 35 hundredths. So I've got a full thousandths of a mil difference in the ovalness of the cylinder here. That's not terrible, and just this one cylinder would probably be okay, but I've already done 4 of these, and I know there's 2 of them that are just completely out of whack. They're coming up to about 8/1000ths of an inch of ovalness of run out, and that's probably out of spec. That's going to cause 2 problems when you're putting your engine or running the engine. First of all, if you could imagine your cylinder ring has a gap, and your piston ring, and if you have ovalness or taper, that gap is going to expand and contract by a certain amount. And if that's too much, it's going to bind your ring, explode it, take your piston out, ruin your engine. If it is too much, it's going to cause a big gap, and you're going to get compression blow by, build up your cylinder gases, and burn oil. So neither one of those is ideal. That's why there's a tolerance of about 5/1000ths of an inch between taper and run out. And I have at least 2 cylinders on the other side that are over that 5/1000ths on run out. So that's it. We're just going to go ahead and get this block board. But I did want to show you that tool. It's really cool, and it makes the cylinders look really good. Let me roll this over here and show you one of the ones I spent 2 or 3 home passes on earlier. Figure out how to get this thing. Roll this guy over. That was my GoPro mount, by the way. It's the magnetic base for my depth gauge. Hopefully I get a chance to use that not too long from now. Figure out my piston height and my piston to valve clearance. Slow down, engine. All right. So these are the cylinders I did earlier. Pristine. If you see that little mark there, that's only because of using the bore gauge. It puts a little mark on it. That would clean up on your final hone pass. Probably just 5 seconds of honing and that's gone. Man, but look at how, if you didn't know to measure these, if you're just going by eyeball, you'd swear these cylinders are beautiful, ready to go. They've got cross hatching, they're clean, but that's why you have to measure everything. Done it. Probably this is going to be the last little instructional video I do for a bit, because I've got to get this out to the machine shop at some point. Even though I want to play with this block, I did a couple other things that are tips, hot rodding tips. I went ahead and I got some little deburring bits, some whatever the carbide bits, and I have smoothed out the transition area around the oil drain back holes at the top of the block on both sides of the main galley. There's 4 on each side, and up here I've got the block facing the wrong way. My light's not in it, but I smoothed out the transition where the main oil drain back goes into what would be the timing chain cover and drops down over the timing chain and then towards the mains. Did that on both sides, got that nice and smooth, got all that casting flash and that hard ridge out of it. Then back here on the back oil drain, let's see if I can find a way to do this so you have some light. Oh, perfect. So there's a big casting problem here where you got flash and a hard line here that stops the oil, creates a friction ridge, you know, the surface tension of oil when it is going to stick to itself, and then only after it overcomes that surface tension by gravity is it going to flow down. We want to make that as smooth as possible. I got some more work to do. I want to smooth out the areas here between the lifter bores to get a nice flow path for it. I did the other side oil drain back hole there. And then on the bottom of the block, there's even more to do. Oh, it's flying around on me. Here at the oil pump mounting surface, I haven't cleaned this, so it looks like ass, but went ahead and smoothed all this out, smoothed the transition out here for the main oil drain from the pump. Here at the oil filter port, smooth out these areas here, and even down deeper, way down there where it goes between the oil pump and the oil filter, the main channel, smooth those transitions as well. There's some more things you can do to improve the oil flow, and I might do them. You can chamfer the oil holes for your mains, and they have the same deal. They have just the factory cat drill right here, so it's got that hard lip. You can chamfer those so it has a nice smooth transition, get more oil flow out of that. And one trick I saw from one old crusty guy on the internet, really intriguing. Here at the front where you have your main galleys, he took a drill bit and he actually made these wider. He had like a 24-inch drill bit and he hogged out the entire length of the oil galleys, increased them by about 1/16 of an inch on all three. Went from like 5/16 here to 1/2 inch here, and smoothed out the bore for the oil passage. Obviously that's a benefit, but it also made it wider so it holds more oil. You get more oil flow through there. These blocks were not priority main type blocks from the factory. The oil went to the top, to the valves, lifters, and cam before it ever made it through the crank. So on startup, your crank was the last thing to get oil, which has been corrected. All these new blocks you can buy from Dart or Scat or whoever makes those blocks are now priority. You can get priority main ones where the galleys have been reworked so that on startup, the oil feeds the crank first and then works upwards to the valve train. That's a really good idea. But anyway, that's where we're at. If you have any questions, leave them below in the comments. And I am done playing with this guy. Tomorrow I'm going to give her a really good soap and water bath and then good air and towel drying, blow out all the galley passages, and give her another WD-40 bath and wrap her in a plastic bag until I get it to the machine shop to help preserve her. So thanks for watching. Like and subscribe if you find all this interesting, useful, entertaining, humorous. Even if it makes you feel better about yourself making fun of me. Hey, I'm down. Go for it. Doesn't hurt me any. But thanks for watching, and we'll see you later.